Hello and welcome to Education at SSBJ online video tutorials. We were in the chapter Motion of class 9th. In the previous video tutorials, we were solving problems related to equations of uniformly accelerated motion. To remind you, what are the equations of uniformly accelerated motion? We have three equations, that is V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as, where small v stands for final velocity, small s stands for displacement, small u stands for initial velocity, a is for acceleration, and t is for time taken. Already we have solved few examples on these equations. We'll take example here. A cyclist is traveling at 15 meter per second. She applies brake. So she is traveling 15 meter per second and then a brake is applied. So let's say that she is moving in 15 meter per second here at this point, and therefore the initial velocity, which is the symbol which is used, u, is equal to 15 meter per second. Then she applies brake. After that it travels for some distance, but there is a wall which is at 18 meter away from her. So when she applies a brake, her speed reduces. It suddenly doesn't become zero. It reduces, and finally this is wall, and then she should stop very close to the wall, right? So we can take this total distance to be traveled by her as 18 meter. And what is the symbol for distance? Yes, right? So again I am reading, a cyclist is traveling 15 meter per second, which is considered as an initial velocity. She applies brakes so that she does not collide with a wall 18 meter away. So yes is taken as 18 meter. What deceleration must she have? And what is deceleration? It's a negative acceleration, right? And why it is negative acceleration? Here velocity reduces. Obviously, when the brake is applied, velocity should reduce. And therefore, for every second, how much of velocity it reduces? And that is what the acceleration. Since velocity reduces, our answer should be in negative. So we'll get answer negative of some number meter per second square, right? I hope you have understood this properly. The situation, u is given, s is given, and one more thing which is to be given, which is to be taken here, is final velocity. Now quickly think of what is the final velocity in this case. She applies a brake and finally she is going to stop here, and therefore when she stops, that is a rest, and so final velocity is 0. So with this information we'll go ahead. As usual, we have to start with information which is given, because there is a mark which is to be given for this information. So you should not skip this. And what we have discussed here is u, that is initial velocity, is 15 meter per second. Final velocity, since the cycle is going to stop very near to the wall or at the wall, it is going to be 0. And then distance is given, that is 18 meter. Now look at this meter per second and 18 meter both are in SI units, standard international unit. So there is no issue for us here to change the units. And what is asked? To find. To find, we have to find acceleration here. And that acceleration will be negative in our case. That is what is called deceleration. Now we have three equations. V equals u plus at. Should we use this? We can't use this because time is not given. We have to find acceleration. But to find acceleration, rest of the things should be there in given. So time is not there. Okay. Now go for the second equation. S equals ut plus half at square. Once again it is combined with time, and time we don't have, right? The third equation is v square minus u square is equal to 2as. Now check this equation. We have v, yes, and then we have u, yes, and then we have even s, that is 18 meter. And now we can find acceleration. Out of the 4, 3 quantities are given in numbers, so we can find acceleration in this. So formula is v square minus u square is equal to 2as, which is the third equation of motion. So let us start doing calculation here. V square minus u square is equal to 2as, or I can write 2as is equal to v square minus u square. So why I have written like this? I want a, right? Therefore a is equal to v square minus u square divided by, since it's a multiplication here, when these other than a, when these s and 2 goes on the other side, it will be division. Okay, that's why v square minus u square whole divided by 2s. Now we'll substitute the values. V square is 0 minus u square, that is 15 square, right, divided by, so I'll put it in bracket, 15 square divided by 2 into s, and what is s? 18, right? And that equal to 15 square is 225 divided by 36, right? And the answer will be equal to 6.25. But remember, this minus sign will stay there, right? That is minus 6.25 meter per second square. So we had missed this minus sign here. We know that velocity reduces, and how much velocity reduces per second? In this case, velocity reduces by 6.25 meter per second for every second, and that's why the acceleration is 6.25 meter per second square. Since it is reducing, that's why it is minus, and you check this here, the minus remains there itself. Okay, minus into bracket 15 square, right? So 15 square is equal to minus 225, minus remains, right, and divided by 2 into 18, and that is amounts to 6.25 meter per second square. We'll go ahead with next problem. A car acquires a velocity 72 km per hour in 10 seconds starting from rest. So before it starts, it was at rest, and therefore we have the information u equals 0. U is initial velocity. Now time is given 10 seconds, that is 10 seconds, and velocity is 72 km per second. And what is this velocity? This is the final velocity, because car acquires a velocity of 72 km per hour. Now therefore the final velocity, the letter which we have to use is a small v, and that is 72 km per hour, which should be converted into meter per second. And how can we convert it to meter per second? 72 into, a shortcut is 5 by 18, you have to multiply. So 18 ones are, 18 fours are, and that is equal to 20 meter per second, and therefore we have got this final velocity into the standard unit. So we have converted this. Find the acceleration. The first question is find the acceleration. So to find a is equal to question mark. Now it's very simple one. V is equal to u plus at should be the formula, because there is no mentioning of a distance here, because distance is not given. And if v is equal to u plus at, then u plus at is equal to v, right? And at is equal to v. So this comes to this side minus u, and therefore a is equal to v minus u by, this will be below, that is as it is a multiplication, and on the other side if you shift it, it becomes a division. So therefore a is equal to, v is how much? 20 minus u is 0 divided by t, and t is 10 seconds, which is equal to 20 by 10, and that is 2. Since it is acceleration, we should not forget the unit, 2 meter per second square. This is the first part of this problem. Answer is 2 meter per second square. Now let us go for the second part of this question, that is average velocity. For that we shall make some space here, we'll erase and we'll keep only the information here, but here we need to find average velocity, right? Before we go and calculate average velocity, I want you to just focus on this particular example. Let's say that an object can be a car or a body. I'll just make a small cube. It's an object which is moving in a straight line, right? Now when it moves, its velocity is changing. So let me write here, for the first second it was moving in 2 meter per second, and second the velocity changes and it became 4 meter per second, means the velocity is increased. Third second the velocity becomes 6 meter per second. So now you will find a pattern here. And what is that pattern? There is change in velocity. And how much change in velocity? 2 meter per second for every second. And what do you call this type of motion? Is uniformly accelerated motion. Please remember that this type of motion is called uniformly accelerated motion, because velocity changes in equal amount for every small intervals of time, right? Now suppose if you are asked to find out the average velocity here, how can we find out? Now if you look at this particular picture here, average can be in the center, isn't it? So the answer should be 4 meter per second. It cannot be a 2 meter per second or 6 meter per second. It should be somewhere in the center. That is called average, 4 meter per second. Now how can we put that in the formula? If suppose this particular velocity, if we refer it as initial velocity, that is 2 meter per second, and then this is a final velocity, v is 6 meter per second. You all know that u is initial velocity and v is final velocity. Okay, and average of these two, u plus v divided by 2. That simple mathematical calculation it is, and that becomes 2, that is initial velocity is 2 plus final velocity is 6 divided by 2, that is 8 by 2, and that is 4 meter per second. So this is what the equation to find average velocity. What is the condition? The motion should be uniformly accelerated. Other than that, you cannot use this equation. Suppose if a body is moving in a straight line, okay, let me draw, consider this is a straight line, 1 second, 2 second and 3 second. If it is 2 meter per second here, suddenly you raise the accelerator, it became 16 meter per second, and then it is 1 meter per second. Now this is not uniformly accelerated, because here the velocity is changed by how much of amount, right? 14 meter per second, and here how much? 15 meter per second down. Now in this case we cannot use this equation, right? So this average velocity equation should be used only for a uniformly accelerated motion. And what is that equation? U plus v divided by 2, and we are going to use that now. Let me rub our board again. So to find average velocity is equal to initial velocity plus final velocity divided by 2, right? Because it's a uniformly accelerated motion. And here look at this, this is the initial velocity 0 plus final velocity is 20 meter per second, that is 20 divided by 2, which is equal to 20 by 2, that's equal to 10. Since it's a velocity, don't forget it's a meter per second. So we got the second part of the answer, average velocity, which you have to write a capital V. A small velocity stands for final velocity. This is final velocity, right? It's a final velocity. But when it is written capital V, it's an average velocity. And how much is the average velocity? 10 meter per second, right? What is left now? The distance traveled, right? And now we are going to calculate distance traveled during this time. And what is the formula which is to be used? We all know that speed is equal to total distance traveled divided by time, right? Or if you consider this as a velocity is equal to displacement divided by time, right? So here the velocity is average velocity and the speed is average speed. Now in our situation here, the speed and velocity are same. Why they are same? Because we are dealing with the situation where the body goes in a straight line, linear motion. If there is no change in direction, a speed is same as velocity. Distance is same as displacement, which we have studied in the beginning of this chapter. So we can consider distance as displacement and speed as velocity in this problem. So how to find out the distance traveled? If the velocity is equal to displacement by time, that is, I will shift this portion on the other side here. Displacement divided by time, let me go in slow, is equal to velocity. Therefore, displacement is equal to, it's a cross multiplication, velocity into time, right? So this is what the actual distance which we require for this problem, right? So simple equation. And which velocity is this? This is the average velocity, neither the initial velocity nor the final velocity. And how much you have to take here? 10 meter per second, not this 20 meter per second. Average is 10 meter per second into how much is the time given for us? 10 seconds, and therefore the total distance covered will be 100 what? Meters. So distance I can write here because distance is equal to displacement. So distance covered is 10 meter. So now here I can use a distance equals 10 meter. That's all. Thank you.